I'm going to be speaking about TypeScript runtime guard libraries. So we have this discussion coming up on our UI team every now and then. We have types all throughout our application, but then we interact with the API and it sometimes changes and we don't expect it, and things will crash or won't work and our types are out of date. So wouldn't it be nice to just run type checkers live on the code, not just at compile time, but actually at runtime? So actually about a week ago, we had a long conversation about this. I wrote this pretty detailed type guard for one of the resources I was using, and some of the team pointed out that, hey, this is a lot of work, a lot of complexity. It takes a lot of time to write these quality checks for every property, and so 3 reasons why it's questionable whether we should do this. 1, the time it takes to write it. 2, if you run it in production on every single thing you're getting from the server, I guess is going to take a bit of performance hit, potentially. And then 3, you might throw errors to the user when you otherwise might just get lucky and not get an error. So then somebody else said, hey, at least we could run them in dev, right? So if we could at least run them in dev but not have to write them ourselves, then we would be interested in that. So I'm going to be speaking about some of these libraries which will do a lot of this work for you. And then when would you use these things? As I said, for us is the API responses, but you could also definitely use it when you're reading from a file that the user uploaded or from local storage in case multiple things access the same data and things don't match the type. So credit to Alex for finding some of these libraries that we're interested in. So I'm going to go through 4 of them, and there's no particular order, but I ordered them by the initial commit, if that matters at all. Just like in case one is like really old, I would like to know about it. But they're all very recent. Like they're all maintained like to last week basically. So they're all really good. But you can see just an idea here of like how popular they are. And this last one is not a 1.0 release, but it's still really good, even though it has less stars than the other ones. Okay, so by the way, anyone here who contributed to these or is using these right now? Oh, okay.
Supplied a comment. Not a comment, but a comment.
Oh yeah, cool. Awesome. Yeah, maybe you can give us some ideas on this. All right, so first one, run types. So yeah, there will be a lot of similarity between all of these, but I'm going to point out the unique things, why some benefits to why you may want to use each. So first one, run types. It's basically a way to compose validators. So there'll be validators for primitives like numbers and strings, and then literals like enums, arrays, tuples. Records would be just basically an interface that has all the properties of different kinds. And then unions, which I guess joins records together, and then intersections and more. So an example here, as you can see, you're importing these run types from the library. And notice that like number and string, they're not coming from the TypeScript number and string. These are an actual run type, which basically comes with a type check, type guard in it as well. So I'm defining, this is from their GitHub, but basically defining a few types here. So you can see first I have a tuple. Asteroid is a record, which you could think as interface. Type literal, that'll be the enum, the value asteroid. Location has 3 numbers, I guess X, Y, Z. So yeah, these are the types here. And then the last line here is actually how to actually use it. So you notice each run type has a method called check. It also has a very similar one called guard, which I didn't see the difference, but you can check if you have the object that you're passing in, if it matches that interface that you provided. So they're really called run types, not interfaces, because they have all these type guards on them as well. So you may ask, okay, so what happened to my interfaces? What if I just want the interface? That's when you use the static type inference that this library has. So when you define your records like this, that's the equivalent of this. So you can see that there's an interface, but it's wrapped in the run type type. And then if you want to extract just the basic interface, you'd call this static thing they have here, and you get just the basic type that you would that you can use to pass around if you need it elsewhere. And then, so that's basically the gist of how it works and how to write it. But then a few nice things that it has that I'm not sure if some of the others will have this. A nice one is pattern matching. So imagine you have a function that you want to be able to pass different types to it, and it will decide what to do based on the type that you're giving it. In this case, if it's a number, you multiply it by 3, but if it's a string, you give the length of the string. Another nice to have is constraint checking. So here, I take the run type called number, and I create a new one, calling it positive, and I give it the constraint, and now when I run the checker for it, because all the run types have this check method, you'll throw an error if it, because it's not a positive number. And then you can also give them a name. Therefore, you'll get better error messages, I think. Another one is function contracts. So again, contract will. I don't know if that's a run type. I guess it is, but yeah. So you have you want a function that will only accept a certain type of run types as their parameters. So like the first two, these two are these two parameters, and then the third one is the return type. So you're putting a constraint, or you're defining a contract on what you allow to go into that function. So it's going to throw the errors for you with the meaningful error message. Yeah, so it can really help as you're doing validation on forms or on API responses, things like that.
Excuse me, on that error being thrown, is that at compile time or runtime?
I believe at runtime. Yeah, because as you're executing this function, it's going to choke on the constraint there. Okay, so again, some more. So it has a lot of flexibility. I didn't go through all of the possibilities here, but another one I'll point out here is you can combine them. So you see a military ship is a ship, and it also has these properties. And record, again, is the interface. And it has the enum, literal military, and then this is optional. So you have an optional property. You can also have number or undefined. But yeah, you can see that all these, like you don't just use the null keyword, you use like uppercase null because it's probably a run type from the library. So that's the first library. It's fairly compact, and it just gives you what you need to have these runtime type checking. Fairly straightforward. The next one, IOTS. has a bit more options to it. It's very similar to the first one. It's a lot more popular, and it uses a lot of functional programming. So it has a pure dependency on the FSTS, I think it's called, the functional programming library. So this one focuses a lot more on deserializing and serializing your data, so encoding and decoding. So besides just giving you the type checks, it also helps you encode and decode data. So on the server, you may use like snake case versus on the UI, you may use camel case, or the dates may be in like JavaScript dates on the client side, but on the server, they're like IOS, ISO strings, for your dates. So this library will easily allow you to specify those conversions. And they use something called codec. So for each of your interfaces or records, you generate what's called a codec, and it's a runtime representation of type A, as you saw here. So there's 3 types here. A is the actual type, and then O for output, I for input. So it's able to decode inputs of type I through the decode method, encode outputs of type O, so that will be the output of the encode method, and it also has the guard, like the other library did. So this is basically the interface, or what a codec looks like. You can see it has a name, it has the guard, validate. So the validate will succeed if it's able to decode, and then encode and decode. And this is an example. So this one is written like you'd write yourself, but then you don't have to do this every time. Yeah, so it's gonna throw an error if it's unable to decode. So this example is what more likely you'd use, like you'd let it do the work for you. So you give it the interface, and it's gonna kind of do a best guess at what decoding and encoding will look like. And then when you have the response from the API and you're trying to decode it, and it's not right, it's gonna throw an error. So it's gonna parse it, and it's either gonna, it uses the either type from I think from the FSTS library. So it's right means it's good, left means it's if there's an error. Also has very advanced ways to write error reporting. So like as you are encoding and decoding, serializing data, you can write your own error reporters. But it'll tell you exactly where the error happened, where it was unable to decode something. As I said, it has more advanced types than the previous library. So like it has something called recursive types. So imagine you have a type category that then has nested categories inside of it. It has a utility method called recursion, and it's gonna basically, you give it a hint to what the type is gonna look like, and it's gonna just recursively check at runtime. And this is a step up from what TypeScript would give you, because it's unable to infer the types recursively. Then example here, mutually recursive types. I guess very similar to the other one, but I don't know when in practice you'd have this, but if you have 2 types that kind of can have each other as a property, then you'd need this utility method. Exact types means you don't allow extraneous properties. So you can see in the are both of these the same? Anyway, it makes sure that you have exactly the the right type, and it's not. Oh yeah, so the first one is user. It doesn't care that there's extra properties, but the second one is exact. So it will complain, and you'll see that some of the other libraries also have this. It also has branded types, custom types, and generic types, which I'm not going to go into, but these are, as I said, compared to the previous library, this will allow you to do a lot more if you have a more complex application. And another nice thing it does, it has a library that integrates with React. So at runtime is going to check all your React components to make sure you're passing the right props, that you don't have extra properties on there, and also the types for the children that you pass to your components. You might pass a string, or it's a React node, for example, as a child to your component. It's going to complain if that's not the case. Another integration it has is with Express. So if you're using Express with Node, you can add it as a middleware, and all of the API calls, you can easily validate all the inputs to your APIs. All right, so that was IOTS, and the next one is QuickTime. So all four of these libraries are written in TypeScript. If you look on their GitHub, it's all 90% of their code or more is TypeScript, and so is this one. But what's interesting about this one is that it's not only used for TypeScript. So this one is used for like a dozen languages or so, and what it does is it generates your models from JSON schema. So you can give it a snapshot of JSON data, and it's going to guess what the model should be. For different languages, it's going to create those. And also, if you're using TypeScript, possibly for other languages too, but for TypeScript, you can ask it to also generate type guards. And not only can you use JSON as a source, but you can use TypeScript as the source to generate models for other languages. I'm gonna go to their website real quick, their playground they have here. So on the left, you can choose what the source of your data is. So normally JSON, or you might have TypeScript. So in our case, for example, an issue that we have is we get mismatch from the backend and the UI, but we don't have a JavaScript or TypeScript backend, so we can't easily share the same interfaces. We have Python and Go, so we want to. A tool like this would be nice because you can generate the models from your TypeScript. Except for us, usually it's the backend drives what types we get. So I'm not sure exactly that we can use this at the moment, but anyway, it's nice to have. So how would you use it if you right now are using TypeScript? You'd put your code here on the left, and then on the right, you need to check this flag here that says verify the results at runtime, because otherwise you just get the interfaces. But if you check this, it gives you the type guards for it as well. So it gives you the functions to encode and decode data, but also all the runtime type guards. All right. All right. So that was QuickType. So I didn't go into too much detail here because it's not a TypeScript specific tool. It's more, it gives you a lot of flexibility with other languages, but it's not something that like the other ones give you specifically with TypeScript. But it does give you the guard functions. So the last one is TypeScript is, and this one is kind of in a different category than the other ones. in the way that it functions in particular. So it's a transformer that generates these type guards for you. And what is a transformer? So what this one does is it writes the type predicate functions. So a transformer is something you give TypeScript to process your abstract syntax tree. And TSC, the compiler, does not support custom transformers. So in order to use this tool, you have to specify the transform, but you also need to use a separate compiler. You need to use TTSC instead of TSC, because this one will let you have a custom transformer. There's an issue that you can go vote on if you're interested in having this supported in just TSC. But how does this work? So the reason I like this one a lot is because you don't have to change the way your current code looks like. You simply add a few annotations to your code. So import is, for example. So you say, you add these. So I don't know if this is the best example, but like you can use is, and you don't have to provide a function checking if something is a string. You just ask it what you want it to check for you, and it will do so. Let me give you a better example, maybe. Like if you have an interface, and you want to check that an object that's passed in at runtime matches that interface, you just ask it if it's that interface. So it's very straightforward to use. You don't right now, like you just replace your custom function that you may have right now. We use a lot of checkers type predicates that we have written ourselves, but we just replace that type predicate with the is function here. What else does it have? So you can, it has these assert functions that you can run on an object. So you assert that something passed in is a number, for example. So I'm sure you're familiar with these if you write your own for the same thing. So what I'm trying to get at is that you don't need to change like the way your interfaces look and the way your types look. You just replace your type predicates or your assert functions with the ones from this library, and you're good to go. It also has decorators for classes, so something that will automatically validate your class methods. So you basically just add that to your class, and then in the methods you ask it to assert the type. So now at runtime, you'll throw an error if the type doesn't match. Like one of the other libraries, it checks for superfluous properties. So here, an equals function. I guess you could do that with Lodash or whatnot, but it's, here it's going to check that the type is just exactly the interface, not with extra properties. Because TypeScript, even at compile time, TypeScript won't usually complain if you have extra properties. So that's an overview of that library as well. So if I was to summarize the benefits of each one, for run types, I think it's really good for validation if you need some very complex pattern matching, or mainly for validating forms and inputs like that, like from responses from the API, checking type constraints, function contracts. And then IOTS is really good when you need to serialize and deserialize your API responses, which we have to do that all the time. Like a lot of our interfaces in our app have the name of the interface and then the remote. So like, I don't know, a user and then remote user, because it rarely matches. So we always have to do this decoding and encoding. And as you saw, it has more advanced types and error reporting. QuickType is good if you're trying to integrate with other languages and you want to create models from JSON or from TypeScript. And you also get the type predicate functions or the type guards. And then TypeScript is, in my opinion, is the most minimal syntax disruption. Like it's not, you're not going to have to change much of your code. Mostly just replacing your type predicate functions. Yeah, so you get, the benefits are more automatic than in the other cases. So yeah, from what I've studied, I think I would go with that one for what we need right now. But there's something about all of these that would be nice to have as well. So anyway, that was a quick overview of these libraries. You guys have any questions, or are you guys dealing with these issues at all, and how do you deal with them? Yeah.
Maybe another question with a comment. We were using QuickType because we have a backend in Go and a client side in TypeScript, and we tried to synchronize among them, and we found it very helpful to embrace the idea of JSON schemas for that particular use case. However, we were not really happy about the quality of the output from QuickType for TypeScript specifically. Therefore, we're still using QuickType for the Go types, but we moved to JSON schema to TypeScript, that library, for generating the TypeScript files. So that was a better option for our use case.
Mm-hmm.
What were the shortcomings of QuickType?
QuickTime, I think it was not dealing well when we were using references to other files, like across the files. And I think it was giving some cases where there was quite a bit of any, or even duplicating the same entries multiple times with just different names, which made it harder to reuse.
Mm-hmm.
So what do you use to convert your?
JSON schema to TypeScript, that's the library.
Oh, okay. Yeah.
Yeah, there are probably quite a few. As I was studying these, there are quite a few libraries that do similar things, but these are the ones that are the most popular. But doesn't mean they're the best. I'm sure there's other ones coming out all the time. So.
Not in the concept of TypeScript, but there's a library called Joy, which is just JavaScript.
Yes.
Works amazingly well.
Yep.
It's saved like a very large
Yep.
project.
I use that one on a Node.js project. Yeah, it's from Walmart Labs.
Yeah.
That's probably the most popular, and like especially for middleware with Express or with Happy.js or yeah, Joy with an I, J-O-I.
What is TypeScript is? I mean, I'm in the code base, but do you have
So it's a transformer. The way it works is yes, it looks at the AST. So like if I go back to some examples, so like it will understand these annotations, and then it will know to add in the type guards. So like it will basically change your code, right? It'll transform your code. Yeah, so at compile time, it basically adds in extra code that's going to be used at runtime.
So
That's how I understand it, at least.
It won't take a JSON payload and do anything to it. It's strictly compile time.
Yes, so like it
It
changes your code basically. So like it'll change the JavaScript that comes out at compile time, and then at runtime, you'll have access to those auto-generated type predicate functions and stuff like that. Other questions? Does anyone use a lot of type predicates and type guards that you write custom? Yeah, we. Mhm.
JavaScript.
Yep. We have a fair amount for, like, I don't know, like if we see an error with an API response, or we also check for nulls, strings, number. Is null. I mean, you can get some of those from Lodash as well, but yeah, I think we're gonna try to settle on one of these because it will save us a lot of time having to write. Like if you have a big object and have to check every property, it's all nested. It takes a long time to write them by hand.
But why do you have to do those checks on the client side? Why not depend on the server side being the authority and the client side just blindly following the types that the server side somehow provides you?
How would the server
Doing the validation on your end explicitly?
Yeah, how would the server or how would the backend provide the types though?
JSON schema, for example, if the server is either generating the JSON schema or abiding to, then the validation can happen on the server side where it needs to happen anyways. So then you would not need to do anything really on the client side as long as you just implement exactly the same types.
Yeah, that makes sense.
It's a third party.
Unless you have a third party.
We don't have that much control of the back end.
Yeah,
It's kind of the Wild West, and we like to just insulate ourselves from.
It's a good use case, yeah.
Yeah, we're definitely looking for a solution so we can have the same types. Like that's a slightly different problem that we're working on as well, is how to have this, solid type contracts between the back end and front end.
Our main boundary there is that the middleware is kind of our bottleneck right now. So if anyone's like looking for a middleware job, we need help. All hands on deck. Right now we've got extra UI cycles, so we can do things like investigate type guards, but the middleware just can't take the time to add new schemas or anything like that. They're using untyped Python right now. They just migrated to Python 3, so they're ready for type annotations, but they haven't started using them yet.
There's actually a very great thing for my own exploration regarding JSON schemas is a library called Fast API in Python, which actually generates JSON schemas from the server-side types.
Ah,
So
that sounds relevant.
I haven't tested it, but my coworker was really selling me on this, and that's maybe the reason why my next language that I want to learn is going to be Python.
What was it called? Fast API?
Fast API.
Yeah.
Fast
I wrote it
API.
down.
Yeah, I am writing that down. Thank you.
I think the only thing is if you're for some reason using NumPy, be careful. Because it gets real weird. Like if you're using MyPy, if you're using the typed Python, but then you have like NumPy in there.
It doesn't work with
well,
full type.
it's just somebody asked a question on Gator today, and I went and looked it up, and I was like 40 minutes later, I was like, what am I doing? It doesn't go well.
That's good to know.
Yeah.
Luckily, that's mostly probably our data science